Oh,
Okay, so we're live right now. So I think you have the floor.
so I'm using the screen share and on this one. Okay, so can you see the screen with the project proposal slide?
I think I made you share to everybody, but for some reason, there we go. Other one, right? Yeah, so I can see your icon has changed, but I don't see. Did you click on present to everybody up in top?
You're on the wrong one.
Yeah, it is saying. I mean, I can see that you are screen sharing and presenting to everyone.
Very good. Sorry, I was my pilot error.
Okay.
Also, we have Madan joined us too. So, good morning, Madan.
Okay. Hi, Madan.
Hi.
Okay.
All right. See everything. Very good.
So shall we get started?
Yep. It's all yours.
Okay. Right. Okay. Yeah. Thanks, TST team for taking this time, and thanks to the community who might be watching this video either now or later. So thanking in advance for the feedback and the guidance on what what we are trying to propose and see how we can contribute to ONOS. So we have three project proposals to discuss today, and we can cover all of them, and then based on the interest and the feedback, kind of try to nail down which ones to basically go after. So the three proposals that we have are number one, the hierarchical controller. Number two, multipath switching in non-SDN and hybrid networks. And number three is the Yang-based intent specification. So proposal 1 and 3 have essentially kind of is brainchild of Tanuj. So I'll let Tanuj speak about it, and I can cover the proposal 2. So Tanuj, over to you. You can potentially cover the hierarchical control connection.
Okay.
Okay.
So, I don't see that in the screen the PPT is changing actually, though in the application I have changed it. I'm not sure. Is there something that I need to do to change that?
Well, are you sharing full screen, or I wonder if it's because maybe just the wrong screen is being shared, because we could see only the sort of the regular editing view of the PowerPoint, but we could not see the projecting.
I am sharing the PowerPoint application. So
yeah, that's probably the problem. I would probably suggest sharing the screen if you can do that.
yeah, sure. I'll share the screen. Oops. Okay. So so now can we see the slide on hierarchical SDN controller?
Yep, you can.
Okay. Yeah, what do you, Tanuj?
Yeah, okay. Thanks, Arun. So here the idea is like we already have the flash structure implemented in ONOS, the basic distributed mechanism, right? So we thought of implementing one more way of connecting the controllers to a hierarchical structure. So here the main idea is, instead of each controller caching the complete network topology, only the main controller, root controller, will cache the complete network information, and the local controllers will have only the local view. So the next, Dharan, can you move the next slide? Yeah. So the design is basically is based on this name called contour design. So there is a two-layered design actually. It basically have a root controllers and multiple local controllers. So you can see a screenshot, the block diagram, the next slide. So basically the root controller and you have the local controllers. So what the root controller will root controllers have the complete topological information of the complete uh, networking structure, and the local controllers will only manage their local switches and local connections. So all the local events are handled by the local controllers, and there is notification mechanism to the root controllers. So this way we can manage like the what do you say much more scalability we can do by connecting in this way.
Okay.
So and even this what do you say the number of events, right? Like in the data path there will be like the events will be much larger. So we can actually offload all those eventing handling into local controllers. Only the like the not much that frequent event that and not frequent events we can give it to that root controllers. So that way that offloading also can happen.
So do you envision the lower controllers exposing the full details of their own topology to the high-level controller?
Yeah, so only the high-level controllers will have the complete topological information, and it will just offload the tasks into the local controllers.
How is that going to help scalability? I mean, unless I guess if you're assuming that the scalability limitation comes from the I/O operations, then
Yeah.
perhaps so. But if the scalability, I mean, there could be other limits that sort of impede.
Yeah, here I mentioned basically. Yeah, you have mentioned basically on the data path the events that we can handle.
Okay.
So to answer your question, so like some of the so it's like you kind of divide the functionalities or some of the things that are which need to be more local, right? Like handling some of the data path events and stuff like that. That can be done by the local controller, and some of the other decisions, right? For example, you have a multi-site distributed network, then you can have the master controller which will have view of the complete end-to-end network, and some of the routing decisions etc. can be taken by the root controller.
Yeah. So can I make a suggestion though? So I mean, so there's a couple of things that I would like to say here. So just at a technical level, it seems like if the high-level controller has a full granularity of the underlying topology, it basically has a complete graph at full detail, you are not really saving anything, because even though the controller does not necessarily have to be engaged in direct conversations with the devices themselves, it still has to be exposed to all of the individual events that occur on the network in all of the different domains. Because otherwise, how can you make sensible connectivity edicts, right? Because if you're not exposed to individual, let's say, link up or link down events, then you don't really have a correct picture of the topology and cannot make sound decisions on it. So my suggestion would be, and this is this is the second point. We've already started thinking about hierarchical and federation. We actually started thinking both about peering as well as hierarchical federation. And there is a team in Italy that's actually working on peering federation right now in Giant. And it's based on an assumption that the neighboring controllers exchange only summarized view of the topology, so rather than full detail of the topology. And this way you get some form of encapsulation or sort of information hiding, so that the peer or even the hierarchical high-level controller is not exposed to all of the events in the underlying topology. And that's, I think, how you get scalability, because if you expose the full detail, you're not going to get any scalability benefits.
Yeah, and usually the benefit of a hierarchical approach is the fact that you can compose it at multiple levels, right? With this, you might be able to do it at one level, but beyond that, it actually gets very tricky, and it becomes a bottleneck. Your root controller.
So my suggestion would be, given the fact that there's already ongoing effort in this area, would be to potentially meet up with the team that's working on this, get their direction, and and then compare nodes. It's certainly no problem with having two different approaches to this, but I would first suggest at least collaborating with them, at least at a high level, before launching on developing this functionality independently. At least you can make an informed decision, right? If after comparing nodes you say, well, their approach is these advantages, but also these disadvantages, and we feel like our own approach would have other advantages, then you can then pursue separate approach for this hierarchical control.
But maybe the question is for them is what's the use case they see for this? Like, is there a reason in particular they would want to expose all the details to them? I can't see one. I don't see why you would want to, but maybe they have a reason.
Yes. Yeah. So I guess this is at least. It's a good question, and maybe I should let you guys answer it. What I gathered from it was the primary goal was increase in scalability. Is that correct, or is there additional use cases that you wanted to cover by this project?
Right. So so scalability and maybe ability to kind of have this working in a multi-site or inter-DC kind of an environment was one of the other use cases that we thought, so so that could be one case. And second thing is basically so for example, you can make the hierarchical controller as a alternate the root as a backup controller for the switch actually. So in case if there is any local controller failure, then you can have a horizontal scalability as well as you can also look at the root as a alternate controller actually, because it might still be having the.
Can I interrupt here? So we already have a mechanism for dealing with failover and for high availability, and that's the cluster itself, right? The cluster itself presides over a single administrative domain, and there is a mechanism in place to be able to provide backup. So I would suggest not making another mechanism for providing a backup controller. So I would rely. Go ahead.
Also, in terms of scalability, and if you're going to go down the hierarchical route, then you really don't want, if you have, like, say, two data centers that you're interconnecting, you really don't want to show the details of the data center itself. It doesn't add any value to your root controller. It just confuses the controller much more and makes things more complicated. Ideally, you should expose the two data centers as a gigantic switch for the purposes of the root controller. Just like Madame and Thomas were saying, it's unless you have a specific reason why you would want the root controller to see all the detail, and scalability is not really one.
Yeah.
There could be another reason, but the ones you've said don't really seem to.
Well, yeah. So for as Ali said, for us, the primary reason we started looking at the federation was actually less so for scalability, even though that's certainly added benefit, but it's more for allowing multiple different administrative domains to collaborate with each other. We found from our discussions with various energy and science network site organizations, CERN, a lot of Fermilabs and other organizations, they need to send large volumes of data from one end of the world to another. But the data needs to transit a couple of different administrative domains. Let's say the data needs to emerge from CERN and needs to be sent to a supercomputer center in San Diego, but it also in process has to transit over some other research network, the transit network. And so right here, you have at least 3 different networks that you need to be able to provision connectivity or reserve bandwidth over. But they're completely separate administrative domains. And the administrative domains don't necessarily want to give you full level of control over all of their individual devices. They just want to give you control over the agreed upon endpoints. And so this is where the need for encapsulation comes in. And an added benefit of providing an encapsulated view upwards or sideways is that it also additionally boosts scalability, because the higher level or the peer controller is no longer exposed to full level of details of the foreign topology, and can actually scale better, because, like if Ali said, if you expose the neighboring data center as a big switch, then you yourself don't have to worry about the details of the topology. You just have to worry about how to request to provision traffic from one ingress of that foreign data center to its ultimate egress point. And then it doesn't matter whether you use it as a transit or as a destination endpoint. So I would suggest actually revising the approach, and then rather than exposing full level of detail upwards, provide a way where you can encapsulate and sort of simplify the topology that's projected upwards. And then notice that this still gives you point. If you decide that you want to expose full level of detail, you can, right? Because you can basically have an isomorphic projection, saying, I will show you my entire topology after all. But if you have the mapping mechanism in place, then you have the option not to.
Sure. And what's your view on the security part, actually? So, like, you have, like, different level of hierarchy and different level of security on the network. Does that sound like a valid use case, even, like, within a single administrative domain? So, hello?
Yes, no, sorry, I was listening, waiting for you to finish. So, did you finish, or?
Yeah.
Well, the thing is, so within the administrative domain, we would have the existing security mechanism where you can manage keys and have secure connection to devices and everything else, right? But then when you expose your picture of the topology, hopefully it's a reused picture of the topology to your peers or to the higher level controller. Right. The higher level controller then effectively deals with what are virtual devices, whether it's one big switch or whether it's some sort of a simplified topology comprising of some virtual devices. He now has control over those virtual devices, and the control over those virtual devices is clearly the access to that is throttled by the northbound REST, whatever API we choose, whether it's a REST API, whether it's some gRPC. But because it's virtualized at this point in time, the host, the sort of the guest controller, which is the higher level controller, can only do the things that the lower level controller exposes. So the security is handled at that level, because no longer you have, no longer we have to worry about what kind of low-level stuff the higher-level controller is going to do to my devices. You don't have to worry about that. So the security there is not much of an issue, because they're not going to be sending OpenFlow messages or netconf control messages directly. They're going to be sending them indirectly through the facade exposed by the hosting controller.
I mean, if anything, the use case for security requires you to expose less information and not more, or like have some sort of projection that you can control security through.
Yeah. So can I suggest?
But there might be some sort of a point where the abstraction that you present has to itself be secure, right?
Yes.
Right.
Yes.
Just the fact that you're hiding information doesn't mean that you're free of security.
No, of course not. Of course not. Right. But the thing is, then the types of operations that you expose would itself have to be secured, right?
Yes.
You're providing indirect access to manipulated device, whether it's through flow objectives, whether it's through intents, or whether it's through some other mechanism. It's still, you need to secure that.
So even if you expose like your entire network as is, I mean that is required, right? But sometimes you don't want to expose what your topology looks like internally for various
exactly
reasons, right? Yeah. So these are two. I mean, both are required. I mean, it's not that like exposing less information requires you to not have ability to
throttle operations exactly. In terms of So my suggestion here would be to get in touch with the Jehan team, see see what they're doing, what approach they're doing, and perhaps you can sort of at least have an informed view of what their approach is, and then see if you want to take either collaborate with them or pursue some sort of a complementary approach. Because
Sure.
right now I think they're looking at peering approach, but maybe you could take what they're doing and apply it in a hierarchical fashion. But I would strongly encourage you to revisit this view where the high-level controller operates assuming full visibility of the topology below. I think that is a problem, and then I don't think that will give you the necessary scaling benefits that you want. Plus, also, it will be undesirable in cases where you're dealing with a hierarchical control over multiple different administrative domains, where you have different organizations owning the different data centers. That'll be a problem, I'm sure.
Sure.
Okay.
Okay. Yeah. So moving to the next proposal. So this proposal is like enabling multipath switching in non-SDN and hybrid SDN networks. So the main business challenge that basically we wanted to target is some sort of say locking in the inefficiencies of loop prevention protocols like MSTP or RSTP, right? So as we all know, if we have a mesh network of Ethernet switches, and if there are multiple paths, STP RSTP would block the paths, and then hence the available links and bandwidth so maybe unutilized. The second challenge is that we wanted to see if the network design itself can be programmed considering the business need rather than you can say a coded logic or an inbuilt logic of RSTP or MSTP, right? And we also saw that there are protocols like Trill and shortest path bridging that have come into play, but all of these would require at least a software upgrade, if not the the hardware upgrade of the switch itself for it to work. So what we thought is that we can using the SDN controller, there can be a way by which we can completely eliminate the loop prevention protocols, and the paths are programmed by the SDN application, so that so they can be programmed considering the business needs and considering several other parameters like QoS requirements, load distributions, etc. So so here the main approach is basically that you take any switch, which supports link layer discovery protocol or any other topology discovery protocol. They may not necessarily be an open flow switch or this thing. It could be as old as 2007 or 2008 when probably LLDP was introduced. We can develop a southbound. We can use netconf or SNMP southbound, or if the switch does not support any of those interfaces, then maybe a CLI southbound. And what the SDN application will do is that it will it will be stitching the topology based on the LLDP messages that it would hear from the switches, and then basically based on the business need, configure the MAC entries statically. Using say for example as simple as a CLI command. So in this diagram, if you see, if we had an STP network, a path where the from F through C1 to B and F to C to B would not have been possible unless it was a it was a lag link. But now with this approach, it's possible that you can have your both the paths active. The business benefit. So to the customers, I mean to the end users of this, what we feel is that it would allow them to have optimal usage of the network with extra bandwidth getting unlocked. And second is obviously flexible and agile network configuration based on business needs. And to the vendors, so when I say vendors, it is companies like the Ciscos and Junipers and Picaites of the world, to basically I mean not Picait, I would say maybe the Ciscos and Junipers who already have some of their gears deployed. They can possibly introduce SDN in the existing networks using non-SDN switches. So so it can allow them to give their customers a realize the business benefit of SDN, even though they do not have SDN switches. And then as as that relationship matures and the customer sees the business benefit, it can potentially generate additional level revenue stream based on SDN software deployment and professional services.
So this is just basically for legacy devices. Because I mean that
it can also work. It can also work in a hybrid environment.
Sure. I mean for devices. I mean for SDN devices, that's basically what you described is what's happening, right? We eliminate all of the protocols.
Yeah.
And
could you go to slide 9, please?
Yeah. So the interface. So the interface would be we may need to develop this CLI southbound or SNMP southbound for legacy devices.
Yeah. Can you just go to slide 9, please?
Are you planning to do this reactively? Like when will you install paths across your fabric?
Sorry, can you please repeat the question?
When will you install paths across the fabric? Are you planning to do it reactively or reacting to packet incoming packets?
Yeah. So the path would be installed reactively. Yes.
Via what?
Reactively.
Yeah.
Through as simple as statically configuring the MAC table in all the switches.
But the thing is if you have a legacy device, the problem of eliminating all loops, right? So you eliminate all loops by using SDN-like concepts on a legacy device. The problem is your control plane is still on the legacy device. Therefore, if you remove all loop detection protocols, your control packets will loop. You see what I'm saying? Like it's not because you have some programmatic control over the CLI that you can avoid and remove all loop detection algorithms. The problem is that the control plane is in the data plane, and therefore things will loop anyway. As soon as you open the floodgates, I mean, packets are going to go crazy. You see what I'm saying? That this is why the STP has a state machine where it goes through a learning phase, a block phase, and then a forwarding phase.
No, so I can disable all the STP, RSTP kind of protocols.
Yeah.
Right?
But if you do, then all hell breaks loose.
I think you're saying everything gets programmed by the controller.
Yeah, but even then, right? So think about
you
this.
have a different control plane. There's a different control plane network, right? There's no control plane. You set up. management network, management network on separate lines or something like that.
But, yeah, so that's fine. But what I'm saying is you're gonna provision. I guess I just don't see. I don't quite get the. I need a little more detail to see how that would work, because the moment you have your fully meshed network, right? So first, any error you make in programming, right, will lead to a broadcast storm or a network melting down, right?
You would basically have to make the switch be like an open flow switch, in that it does nothing until it's told to do something.
Exactly. Right. But the problem is with that is that like a legacy switch, you just won't do that, right? That's what I'm saying. Is that like the moment you open a port up, right, it'll start chatting. Right? Unless you have very, very fine control over the protocols, and the CLI doesn't give you that. I mean, at least the CLIs I've been exposed to don't give you that fine level of control. So, I mean, while this is like interesting, I still want. I think you need a bit of a.
An L2 fabric on open flow.
Yes, L2 fabric. Yes, precisely. L2 fabric on L2 switches. That would be super valuable, and also would be welcomed with lots of cheers. But I worry about these kind of hybrid approaches because they're insanely complicated. You quickly get into all kinds of issues.
Well,
And I think most vendors who have tried to go down the hybrid route have given up, -1, I think, and even then.
I ask you
No.
Sorry. So from my personal point of view, I think the get rid of these protocols. Yes, it's good. It's good. It's simplify the management. It's fine. However, my concern is that you bring in the new algorithms. Does this algorithms is the standard ones, or it's improved or something? So I think keep the prevent the loop is very important and critical in the network. So that any algorithm need to be verified and tested to cover every single corner case. So it's Happiest Mind guys, can you answer the questions for your algorithms? In which scenarios you are covered, and which case? Which standard the organizations currently you're presenting your ideas, especially the IETF, some CC, centralized control working group. If you
So at this point of time, like to answer the question, at this point of time, there is no particular algorithm that we have developed or conceptualized. So this is more like a framework where the algorithm, if you refer the slide 10, the algorithm may potentially be in the SDN application actually. So it might still be at an application level. What as part of this project proposal, what we want to achieve is a framework wherein the switches can be programmed by the algorithm. So the legacy switches can be programmed by the algorithm and not necessarily by STP or RSTP. I mean, so that is kind of a thing. And I'm just building up on the question that one of the team members asked, whether it will be reactive or proactive. I mean, though our initial proposal we were thinking of reactive, but possibly we can look at some elements of proactive configuration as well. So, but we have not thought about the proactive part. Maybe we can think about it a bit more and see how that would work.
okay.
So I mean, I'm still a little bit confused. So you have everything that you would need to do in a platform today, right? You have the southbound. So basically, what you're talking about is creating a set of drivers and providers for be able to interact with those legacy devices using whatever legacy control protocols are in place. that would imply that you would also, at that level, adopt those legacy devices, well, I mean, quote unquote, adopt them by turning off all of their looping prevention mechanisms and also put them in the mode where they would behave in a, quote, safe manner on the network. Do you expect then any additional abstractions would be required to interact with those devices, or would the existing abstractions of perhaps simplified flow rule programming can be used for this, right? So at this point, it's effectively just sort of southbound drivers and providers that would need to be developed for this, right? What do you refer to it as a framework?
Yeah, and so the other thing which we might need is basically to kind of if especially like if we are working in a hybrid mode, some ways for the ONOS controller to notify the application if there is any topology change, and then being able to detect that okay, this topology is in these elements as part of the topology are legacy devices, and hence basically I need to do the routing from I need to configure the paths based on the instructions for a particular application. So that kind of we would need to look at the current implementation in details and see if there are any hooks or interfacing that is required at that level.
Well, that's you just described the function of the providers. They are the ones that interact with the environment and notify the core about the changes in the environment and the structure of the environment, which includes infrastructure devices, links, and station hosts, and any changes to that inventory. The core then stitches it together in a completely protocol agnostic way, and then provides a path service on this, path compilation service, which at the point in time is completely agnostic of anything else. So I'm a little bit at a loss as to, other than just writing this set of the low-level, not low-level, but the lower-level southbound providers and drivers. There's really nothing else to this. My question, and I think everybody's question in the room, is the value of this, because I guess at least in my personal experience, the hybrid problem is an extremely difficult problem to solve. Because the problem is the different legacy devices, and I know this just even like within one company, HP, different models behave differently with respect to STP and other type of ability to suppress completely the behavior of those loop prevention protocols. It was actually not possible to do that in all devices to completely quiesce them.
You can. I mean, some of them you can.
Yeah, exactly. Some of them you could do it on a VLAN, but you couldn't do it on a sort of aggregate level. And basically, I think what you're doing is, unless you have an extremely homogeneous environment where you know certain capabilities of the certain legacy devices and are willing to make certain specific, very highly tailored sets of basically southbound providers, it's going to be very little return on investment because of the huge disparity of the legacy behaviors that exist today. So I think the bang for the buck here will be almost none.
Yeah.
Sure. And what if we basically restrict the scope to just legacy actually? So we don't target the hybrid environment, but say this could be the first SDN application experience for networks where only legacy devices are used, and it's for that, and not for a hybrid. So I mean, will that be useful, or you still see that even in a pure legacy environment also there would be certain challenges which would kind of negate the value of such an implementation?
Yeah, I still the problem is still the same, is that trying to finally control a legacy device the way you do in the same way that you do via OpenFlow is a very, very difficult proposition. The CLIs are there. The CLI commands you have available on the devices are coarse-grained, and they're coarse-grained because they're there for that reason, right? They perform that function. So if you try to shut off most of the features that are necessary to be able to then program the device the way you want to, I just don't see it. I have a hard time imagining how that would really work, unless you're configuring some known feature like building a segment routed fabric on top of a device that supports segment routing, or configuring OSPF on top of devices that support OSPF. That's a whole different story. But to provide your custom application on top of a CLI, I just don't see it. I think it's going to be extremely complicated, and you're going to be tweaking a CLI continuously. And there's going to be all kinds of timing issues.
Yeah. No, I agree. I mean, now certainly you can pursue that. You're free to do that, of course. But that's at least where we would not be spending our time on.
Okay.
So,
Tanuj,
very, very clear, customer that says, we have these legacy devices and we're these family of devices, specifically which ones you have, and we have a pressing needs to be able to do this. But I would not be solving this problem without an explicit use case.
Yeah. But like Jono said, I think in the same spirit as this, a layer 2 fabric, SDN fabric, that would be very, very nice.
It's also very complicated, and there's lots of.
Yeah, sure. I mean, nothing is easy, right? But it's slightly more tractable than this.
That's the most interesting part.
Yeah, it's
the application rather than
so can you please explain how the layer 2 SDN fabric would work actually? So you are saying that we put an SDN switch which kind of creates a is a fabric for a mesh of legacy switches, and then we control through that. That's what is that what you are trying to say?
Forget legacy. They're all open flow switches, and probably even probably switches that support something like OFDPA or have proper production ready pipelines and agents. To describe the behavior of an Ethernet fabric right now off the top of my head will be a strong requirement.
Okay.
I have to. It's not.
So maybe can you send some info on that offline so that we can tune we can refine the proposal considering that input from you.
Sure.
Okay. That would be great actually. If you can send some information, then we'll try to build upon it and refine the approach.
But going back to this specific proposal, I think you have everything that it needs that you would need if you decided to take this project on. But from our viewpoint, we would question the benefit of the exercise versus the effort.
Sure.
Unless you have a specific use case that and a specific customer that would has a need for something like this, I would suggest you take a look at the value benefits versus the effort again, because I think the effort will be large for the reasons that we've stated throughout.
Sure. Okay. So, Tanuj, you can take over from here on the Yang-based inline specification proposal.
Yeah, sure. So this is basically a way to towards a policy-based inline specification, and we choosing Yang as a language to specify that policy. So the idea is to separate out the data models from the control logic, and then have a consistent framework to specify an intent. And Yang, it's of course a popular language among the network operators.
Hey Tanuj, I was not able to hear you. I'm not sure whether the committee was able to hear you or not.
Am I audible now?
you just your levels are a little bit lower. That's fine. We can amp you up. You're good. Go ahead.
Okay. Okay. So we got my initial. The context was set, right? Like I thought like it's a policy-based engine specification framework, and we're choosing Yang as a language to specify that policy. Because since Yang is a consistent framework and it's been used in multiple places, so we thought of using Yang as a policy language. So the idea is this. So we have the intent APIs for ONOS. Like actually, ONOS is an intent framework. So we are building on top of that by using a runtime, so that people can specify the intent using a Yang model, and that can be converted into a ONOS intent specific calls. So I can give you that block diagram for better understanding. Run that block diagram. So here we are reusing that YangForge open source project. So that basically converts a Yang spec into an object model, and that can be converted into a ONOS specific calls.
So the Yang spec is just a spec of the interaction, right? So that's not something.
Yeah,
so that's something that comes from the side. It's basically like presenting a contract. Once the contract has been presented, it's withdrawn. It's no longer part of the interaction. What's part of the interaction is some sort of data format, whether it's JSON or whether it's XML, that contains the actual data and the actual request. Yang is no longer part of the picture, correct? Right?
Yeah, I mean, yeah. Yang is spec on, yeah.
Yeah. So, do you? So what? So let me. I guess I'm trying to figure out. So you're trying to. So your effort would create a Yang model, a well-defined Yang model that defines how to interact with the ONOS northbound. Is that correct?
Yeah, especially that intent APIs. So basically, we are modeling that. Yeah.
There's actually already work that has started towards that. Well, started. There's work that was done a while back towards that effort by Srini. He modeled a few of our intents. Yeah.
I think the Yang shells, basically Yang shell project basically cover this. So
I don't know. I haven't looked at the Yang shell.
Yeah, it is.
I stopped looking when I see.
I can send I already upload the slides into the Google Drives. So we give the talks in the ONS. ONOS, yeah. So we basically is covered. It's exactly same as over here. We support the internal and the external models. So it's the same concept, same implementation. I can send you a pointer to about the Yang shell implementation.
Okay.
So I think in your cases, Patrick, there is actually an application on the ONOS platform. The Yang shell is on the platform, or
yes.
Is it off the platform?
Yes, it's in the platform as the application.
So it resembles more the option 2 in here, right? Where you basically have an application on platform that's parsing that's basically using the Yang. You feed it the Yang model, and it sort of morphs its northbound interfaces according to the Yang model.
Yes. I think the concept here is take a look at the internal ONOS APP as examples. So the intent translator APP basically is the same functions as a model the current intent APIs by the Yang and provide the Yang APIs to the external. The translated is when the external calls call the internal the intent APIs. Sort of the decode the codecs, some things is need to be built there. That's what they call the translators. So it's exactly same as the Yang shell frameworks. We basically we're supporting multiple codecs in that Yang shells. The first one is the RESTful. later on, probably if you need, we can add the more and mores and the RESTconf, SNMPs, and whatever. So basically, yes, your case has been covered.
Okay. Okay.
Okay.
So basically, this is based on a project outside running. So Boulder, have you guys come across that Boulder project from ONOS?
We know a little bit about it, not much.
Okay, so basically that's like a abstraction on top of multiple controllers. So it's like a runtime. It's like how a Java is for multiple OSs. You have one abstraction layer covering multiple controllers on top of their indent API. So we just sort of creating a runtime on top of like ONOS indent APIs that can be extensible also. So it's like a common framework where people can specify indents using a generic language.
So is this part of so is this would you be doing this in the context of any sort of standard or establishing some sort of a standard?
Yeah, so our intention is like that, to establish a standard way to express intents. So
okay, so you probably are you familiar with some of the NBI efforts that are going on, let's say like with ONF?
we're just looking into that. If you can give me some more inputs, actually we can modify this. So we are actually working on that Nemo language, right? So I'm just looking into that Nemo programming language and associated models with that.
So you're working on the Nemo, I think?
I mean, I'm just looking into that actually. So we're just looking into standardizing this indent specifications. We come across this Nemo language, and so we're just looking into that. You can give us some inputs, and yeah, we can.
No, we don't. That'll be tomorrow's bomb. It'll have to be next week.
Okay. Okay.
The Nemo, yeah. I think next week there'll be a presentation on the Nemo.
Yeah.
Okay.
I won't be there, but somebody else.
I think
I'll be in Korea. Yeah. So I guess my recommendation would be just rather to hook in. I mean, clearly the value of these things lies in how widespread the standard is adopted, right? Or the interaction is adopted. Whether it's standard or not, it doesn't really matter. But if the abstraction and the specific sort of form of interaction is widely adopted, then it becomes useful, and then you can then applications can be written to interact with the different controllers using that standard interaction, right?
Yeah.
So I would, rather than to help that effort, I would make sure that we work with the existing. Rather than introducing yet another effort, I would say that we work with either ONF or somebody and congeal the effort behind that. Because there's too many standards to fly, right? I mean, even like L3 VPN has like 3 different models. They're yin-yang, but the fact that it's yin-yang doesn't help you any if you have 3 of them to pick from. And the fact that we would use yang, that's just we're just using a standard form of defining the interaction. That's fine, but the ubiquity of the model, that's really the important thing.
Okay.
So I guess there's a number of existing efforts that pursue similar approach. So there's the Nemo, and I know that the ONF sponsored effort for the NBI is also something that's going to be actually taking concrete steps towards having a model that's supported on ODL, as well as one that the same model that's supported on ONOS, as a sort of a trial run to prove the idea that this is possible to do at a high level, to interact with different controllers using the same abstraction, same mechanism.
Yeah.
So I would recommend learning about those and maybe sort of attaching to one of those.
Okay. Sure.
Because again, while having multiple different approaches is fine, but we're definitely trying to make sure also we don't fracture this space too much.
Okay. Yeah, that's true. Yeah.
Okay.
All right.
Sure.
So I think if there are no further comments, let me just reiterate on what are the action items for Happiest Minds team. Number one, for the project proposal one on hierarchical controller, we should reach out to the current team that is working on the federation project and try to align our you can say effort in line with what they are trying to do, and
Yep.
maybe propose a complementing solution.
Yes.
For the proposal two, as is the business value is questionable. So what we would try to do is take inputs on the L2 fabric suggestion that is there. I mean, once we receive that offline inputs, we'll try to rework on that and see what can be done, which has better business value. And again, for the proposal three, we'll work with Patrick and his group to see how this again can be aligned to the current efforts that are going on with respect to Yang and intent and stuff like that. So that
Yep.
basically and
Yep.
Patrick.
Sure.
That's a good summary.
Yeah, sure.
Okay.
Yeah, we'll work the team. We'll work with the team and get back to this group again with a refined approach.
Great. Thank you very much. Thanks for your time.
Okay, yeah. Thanks the steering team for your time and valuable inputs.
Great. Okay. We'll talk to you later.
Yeah, thanks.
Yeah, sure.
Bye.